Hello students, welcome back. Previously we went through some integration by substitution problems, and they are all elementary in a sense that we had to do only one set of substitutions. Not just one substitution, of course, one set of three substitutions, kind of like this. First substitution and the derivative computation yields the second substitution, red and blue, and the final substitution, number 3, for the final answer. This should be red again, as a matter of fact. Similar thing goes on here. First substitution and then the derivative computation yields first and second substitution, red and blue. And after the integration, substitution number 3. So just one set of substitution, but one set of 3. There are some problems, however, that requires more substitutions. Okay, let's consider this example. Y is 1 plus x squared. That looks pretty much straightforward because we have the inside of this square root. Let's take the derivative. And then so far so good. So that's substitution number 1, and this is going to be substitution number 2. So here that's red and that's blue. So if I substitute all those in, this is y, and this one is 1 over 2x dy. Do you see a simplification? Sort of. What I see is this. X cubed and x canceling out, we have x squared over 2, and then square root of y, let's keep it as square root of y, and dy. We still have a problem here. This one here, which I just highlighted in bold green. Maybe let's take bigger fonts so that you can see better. After those two substitutions, I should be getting y integral, but not yet. I still have some leftover x flying around. I cannot do any computation here with y alone. What do I do now? Suggestion. Well, we have to go back to the original substitution here. From here, x squared is y minus 1, and if you put this one right here, then everything will work out. So the integral will turn out to be, the original integral will turn out to be this. This x squared is y minus 1. And then finally we have a y integral. So shall we work this out? Okay, let's go ahead and do that. 1/2, and then y times square root of y, so that's y to the 3/2 power, and then -1 times square root of y, so y to the 1/2 power. That's the integral we have. And can we calculate this integral? 1/2 was there before, and then find out the antiderivative, 5/2, so I have to multiply by 2/5. One half was there before. I have to add 1 to the power, 3/2, and I have to divide, so 2/3. A little bit of simplification is in order. So 1/5 y to the 5/2 power minus 1/3 y to the 3/2 power. Okay, all right. Is that the correct antiderivative? Yes, it is. We don't have integral sign anymore, and we have plus c and o, but not the final answer yet, because it's still written in terms of y. So I need one more substitution. Copy and paste this entire thing. And then what is y? Y is 1 plus x squared. So this one. Okay. Finally, that completes the problem. By the way, this entire thing was the original integral. Okay, that completes the problem. What do you think? So, previously, we had a set of 3 substitutions. First, red, after derivative computation, blue, and put those in, and after simplification, we had just y integral calculated, and at the final answer, third substitution back in, and that was it. But here, I need 4 substitutions. A set of 4 substitutions. I still have x squared flying around. So going back to the original, we get x squared is y minus 1. Put that in, and that'll create, oh boy, a little bit more complicated integral. Not just power function, but we need some manipulation. And work those out, and then final substitution. So we have a set of 4 substitutions in there. Tricky. Ready for another problem like that? I don't know if we'll have enough time, but let's try. So that's the problem we are looking for. And it's pretty clear this is the inside function. And then dx that we have to substitute. So let's go ahead and do that. Y equals to 1 plus x squared. Good. Derivative dy is 2x dx. Dx is 1 over 2x dy. All good? Red. And then blue. Please check. Did I do everything right? Assuming that the substitution is correct, everything is straightforward. Derivative computation and solving for dx. Okay, let's plug everything in. Then this equals to, let's see, this is y. And then this one is 2x, 1 over 2x dy. And then do we have simplification? This x cubed and this x cancel out, so we have x squared over 2 square root of y dy. That's what we are getting. Can we calculate it? We can, because I still have this leftover x expression. It's not entirely a y expression. So what do? Let's go back to the original. Y equals 1 plus x squared. X squared is y minus 1. And that green goes right over here. So therefore, the original integral becomes this, which is y minus 1 like this. And then can we simplify this? If you have addition in denominator, we are stuck, but addition in numerator, we can always separate. And then what's left is a bunch of power function. In this case, only 2 of them. 1/2 y to the positive 1/2 power function, 1/2 y to the negative 1/2 power function. And then if you calculate the antiderivative, 1/2 was there before, 3/2, and then we need reciprocal 2/3. 1/2 was there before, add 1, and then we need reciprocal 2/1 there. Yeah, okay. So how do you simplify this? 1/3, and then y is 1 plus x squared. 3/2 power. And this one cancel out, just become 1, when 1 plus x squared, sorry about the typo, to the 1/2 power, and that'll complete the problem. Well, not in the same viewing window, I guess. Okay, now everything is in the same viewing window, barely, but they are. Original problem here. And inside of the square root, yes, that's my substitution y. Derivative computation, so for dx, good. And then put everything in, and we have still some left over. We go with another substitution. That gives me a y integral, but then again, this is not a trivial y integral. We need some separation and all kind of work on numerator and separated numerator and then simplification. Eventually they work out, and then you can substitute y equals 1 plus x squared back in. Okay, all right. Theoretically, this kind of problem is definitely within the applied calculus range. We don't have any trigonometry, we don't have any special technique. That's certainly within our curriculum, but realistically, this is going to be a really hard problem if I do write one.